So we'll take one problem and try to do it. So very simple. Only this contains more calculations kind of stuff. So where we have to, this is SST, sum of space statement and sum of space total and sum of space treatment. So where we have to calculate T, which is sum of the data sets what we give, what is given, what we had, and correction factor, that is T square by n, where n is n1 plus n2 plus so on, whatever n's we have. So then we have to calculate SST, SSTR, and the sum of square errors SSE. As shown here. Suppose if we take these examples like this. So to test the significance of variation in retail prices of a commodity in 3 metro cities. So 1010. Now the data is given like this. So we have 3 metro cities, and some 4 outlets are selected, and the prices are something like this are taken. So the prices in the 3 cities are significantly different or the same is the hypothesis we want to or we need to validate. Like someone pointed, it looks like a chi-square dish, but here if you see, so we want to validate something like this: price of 3 cities are significantly different, or that is, so mean is the base for us to validate this hypothesis. That's why we are going for the ANOVA kind of discussion. If it is something related to proportion, then we have to go with chi-square distribution. Now, so another example is like this. Suppose we had 3 types of groups: the marketing manager and marketing research as well as advertising, 3 groups. And where we have their the scores related to ethical values, and here what we want to validate is test for significant differences in the perception among 3 groups at 0.05 level of significance. That means whether high scores indicate higher ethical values or not. That means here whether these 3 groups are having a significant difference or not is the one which we have to, or which we are going to validate. So that identification is very important. Once we are able to identify this is something related to ANOVA, then ANOVA implementation or any kind of implementation is as simple as that. So that identification is very important. So here now we take something called X, very simple here, just it is a mathematical way of solving a problem. So X1, X2, X3. Now there, so in that also we had groups 1, 2, 3, 4, 5, 6, and their scores we had, the corresponding scores. Now we want to validate whether mu1 equal to mu2 equal to mu3. That is, is there any significant difference between the 3 groups or not in terms of the scores they had with respect to ethical values. So once we identify that this is something related to ANOVA discussion, then it's very simple here. So here R is 3, that means the number of groups that we are having, our number of population, that is what we are going to work with. So that is R equal to 3, and N equal to 80 means the total points that we had. So 3 is the groups and every group contains 6, therefore what N is 18. And now simple calculations. I think it is maybe a boring kind of stuff for you. Okay. So here actually we are validating this in terms of the mean only. While doing so, we are taking the fruit of variance. That's why in the beginning I told you. Analysis of variance means it's not that we are validating the hypothesis related to populations in terms of variances or standard deviation. No. Here again we are validating in terms of mean, the hypothesis related to mean, where in the process we are taking the help of variances. That's why analysis of variances. Analysis of variances, we are taking the help of variance to validate the claim or hypothesis related to mean. CF is the correction factor, T is the total, and SS is sum of squares total, right? And SSTR is sum of squares, that is within the groups and between the groups, that is SST and SSTR. So T is the sum of the first group, second group, and third group, that is T. Correction factor is T square by N, and the SST is sum of square total. Okay. This is summation x1 square, x2 square, and x2. I think maybe it is for boring for you. And SST, that is sum of squares treatment, that is between the groups. From this we calculate the sum of square errors. Then from that we calculate MSTR and MSE, as where we have the degrees of freedom, that is numerator degrees of freedom and denominator degrees of freedom. So where we have this is R minus 1, that is R is number of groups. We have 3 groups, 3 minus 1, 2. Therefore, this we get. And DF2, it is degree denominator degrees of freedom. It is N minus R. So that is 12 minus 3. So we get MSE. So once we have this, then we go for test or F statistic, where MSTR by MSE, where we get some value for this, that is 7 here. So this is the value of what we calculated. So based on the discussion what we have within the groups and between groups. So next what we have to do is we have to take the T distribution table, where we have to go for the numerator degrees of freedom, that is R minus 1, and denominator degrees of freedom, that is N minus R. So from the table, I think I missed to copy the table. So from the table for the given alpha equal to 5%, for these numerator degrees of freedom and denominator degrees of freedom, it is 3.68. So calculated value is 7 and the tabulated value is 3.68. That means this 7 is greater than tabulated value 3.68. Therefore, it is rejected. The calculated value is 7, which is greater than the tabulated value 3.68. In other words, therefore it is rejected. This is how we do with the ANOVA kind of problems. Okay. So I think it may not be that interesting, I think, because it contains many numericals and doing calculations. But on the whole, it is one of the good models we use. After chi-square, the chi-square is what we discussed is one of the good models which we use. Then this is also another model which we use. So T is treatment is within the group. Within the group, and T is between the groups. Now, suppose if we take this problem we have. So where we have the data, that is we have 4 sales teams A, B, C, D, and the sales that they have done during the months May, June, July. Okay. So now here actually if you see we want to have the validation some kind of discussion related to sales. That is one way of looking towards this. Another one is with respect to months. Right? So whether all these three groups are significant with respect to the sales that they have done. That is one kind of looking. And with respect to months, whether all the months are having on the average whether the sales are the same or not. Right? Okay. So the data is the same. So we want to analyze this in terms of the row as well as in terms of the columns. That means actually how to do this one. One is the table is F distribution table. Yeah, this I wish it to show it actually. Thought I can copy. T distribution, not T distribution. It is F distribution, Fisher's distribution. Now, if you see this example, how to do it? Actually, it contains two problems. So one is with respect to this. Maybe I can say take as mu A equal to mu B equal to mu C equal to mu D. That is one problem 85. Other one is mu of May equal to mu of June equal to mu of July. That is another set of discussion. That is two hypotheses or two validations I need to do. So that is nothing but it is the problem. If you want, we can take the with respect to rows, we can take as a one problem and we can solve it. And with respect to columns, we can take it as another problem and we can solve it. Okay. So instead of that is one is if we consider as a primary problem, other one is called as a dual problem. So in such scenarios, what we do is we will take the help of two-way ANOVA. So two-way ANOVA is the one which helps us in such scenarios. So here the same discussion, similar kind of things, but only difference is here previously we had only in terms of groups, that is only columns we have. With respect to columns, we have done all the calculations required. In this case, we have to do this with respect to columns as well as rows and in the corresponding residual errors. That is sum of square errors we have to do it. Okay. So that way we have rows as well as columns. Then degrees of freedom also differs here. So R minus C minus 1, R minus 1, and the product of both C minus 1 into R minus 1. So like this, we can take the two ANOVA problem. So what I suggest is we can take this two-way ANOVA problem again. It's some kind of discussion with respect to one-way ANOVA. Some elaborate discussion I will go over it. And one more problem with respect to ANOVA. I think better we'll take for discussion in the coming class so that all can participate in the discussion. Okay. So most of our friends asked for the cancellation of the class, actually, which I don't want to do it. If you have anything specific, we'll discuss. Otherwise, maybe we can take this because this is one of the important concepts, so we can take it further in the coming class. This is what I suggest.